pages. But the focus of this video is fractions. Fractions. What is a fraction? A fraction is a number in the form a over b. A fraction is a number in the form a over b, where a and b are real numbers. Where a and b are real numbers. So examples are 2 over 3, 5 over 6, 1 over 2. These are examples of fractions. And a fraction in reality is a part of a whole. A fraction is a part of a whole. Since if you have a whole of something, you not take a part of it. That's what the fraction represents. For example, if you have a bar of chocolate, something like this. Now, you have this into 3 parts. If you take one part away, the one part to take away can be represented as what? 1 over 3. That is, the bar has 3 parts, not 2, 1 out of the 3. That's 1 out of 3. Another case is where I have, for example, a rectangle dividing the 3 parts, then I shade 2. I shade this part, I shade this part. So I will say I've shaded 2 over 3 of the rectangle. That is, I've shaded 2 out of 3. The rectangle has 3 parts. I shaded 2 out of those 3. So I'll say I've shaded 2 over 3. That 2 over 3 is a fraction, representing a part of the whole rectangle. Generally, that's what fraction represents, a part of the whole of something. Now, there are 3 types of fraction: proper fraction. A proper fraction, that is fraction in which the numerator is greater than the denominator. Also, in a fraction, there are 2 parts. The upper part, say, one above is called the numerator. The lower part is called the denominator. Numerator and denominator. Yes. In a proper fraction, the numerator a is less than denominator b. And you're assuming this fraction is a over b, right? You can say a is the numerator, b is the denominator. So a is less than b. That is, the numerator is less than the denominator. An example of that is 2 over 3, and John we saw earlier, 5 over 6, and John we saw earlier, and also 1 over 2. They are all proper fractions. You can see the numerators are less than their denominators. So they are proper fractions. Second type is the improper fractions. Improper. In this type of fractions, the numerator is usually greater than the denominator. In this case, we say a is greater than b. A is greater than b. If the number above is greater than the number below. Example is 6 over 5, a over 2, 7 over 3. In each of these fractions, you can see that the number at the top is greater than the number at the bottom. That is, the numerator is greater than the denominator. And the third fraction type we have is the mixed fraction. The mixed fraction, or we call it the mixed number. Mixed fraction or mixed number. We call it mixed number or mixed fraction because it is a mixture of a whole number and a proper fraction. A whole number and a proper fraction. For example, this 2 number 1 over 2. You can see the whole number part here is 2. You can see the fractional part here 1 over 2. Whole number part here is 2. Fractional part 1 over 2. And it's a proper fraction. And that example, if you have 3 whole number 2 over 3. You can see the whole number there, 3. And see the fraction there over 8. As a reduced number for the reduced fraction. Now, just like in normal algebra or normal arithmetic, whole numbers where we can perform basic operations, you can add, subtract, multiply. You can also do it the same with fractions. You can also play around basic operations using fractions. Add and multiply and divide and subtract. Now let's start from addition and subtraction. Since we all the same method here, let's do them together. Addition and subtraction of fractions. And the first thing to take note is that for this, there are two cases. Case 1, same denominators. That is, when we want to add or subtract two or more different fractions, and then they all have the same denominators. An example is if we have 2 over 3 plus 1 over 3 plus 10 over 3. To add this 3 fractions, you can see they all have the same denominators. In this case, what do we do? Simply add the numerators. Then they now have the same denominator. 2 plus 1 plus 10 all over 3. You add the numerators together, then they have a common denominator. Why? Because initially they have the same denominator. You can see how we added them. Then 2 plus 1 is 3 plus 10 is 13. 13 over 8. That's how we add here. Another example, we might have more than 3 fractions, we might have 10 fractions. We have 7 over 4 plus 5 over 4 plus 11 over 4 plus 9 over 4. I think there are 4 different fractions here, right? But they all have the same denominator. This is the first case. What we do, we add the numerators together and then we did them with common denominator. 7 plus 5 plus 11 plus 9 all over 4. So we are adding 7 plus 5 plus 11 plus 9. That's 32 over 4, right? So we can simplify further here. 4 here 1 point 33 8. 8 over 1 is 8. Right? Okay. This is for addition. Addition. Let's have for subtraction also. Even that case 1, right? Now let's have 10 over 3 minus 7 over 2. So you can see it. Let's just have 10 over 3 minus 4 over 3 minus 4 over 3. And see, since we have the same denominator, what we do? Simple solve 10 minus 4 and then we take the common denominator of 3. And what's 10 minus 4? That's 6. It should not be. If we can simplify further, 3 and 6 is 2. 3 over 1, 2. Similarly, here we can have some more fractions. We want to subtract. And have 12 over 5 minus 3 over 5 minus 2 over 5. Now, you can see the other have the same denominators. So we simply say it is 12 minus 3 minus 2 all over 5, a common denominator. That's 12 minus 3 is 9 minus 2, 7. 7 over 5. That is the answer. 7 case, every case, means we have different denominators. Different denominators, which is quite interesting than the first case. different denominators. Okay? Let's add for addition first. From we both example here. So let's begin with a simple example. We have 2 over 3 plus 8 over 5. You can see they have different denominators here. So what do we do? So we do what we call LCM. We find the LCM of the two denominators. As for the first case, you can see we only give the two that the denominator, since it's a common denominator, we give the two denominator. In this case, we want to turn these three different terms to a common denominator. So we use LCM. We find the LCM of the two denominators, right? And the LCM of 3 and 5 is 15. So write the denominator here 15. 15 here. What do we do next? Now this is what we'll do. 15 divided by 10 as 5, right? 5 times 2. That's 10 plus the same here also. 15 divided by 5 2 times 3 9. Then we add 10 plus 9 as 19. 19 over 15. That is the answer. Anytime we have to depend on methods, how about we figure out it? Let's add more fractions. 1 over 5 was 2 over 6 was 4 over 2. You can see there are 3 different methods here. 4, 6, and 3. Find 5, 6, and 3. And the LCM of the 3 denominators. You have 5, 6, and then 3, right? With the LCM, you can divide by 3 here. 5, 3 and 6, 3, and 1 is 1. And it's also 5, 1, 1. From 5 here also 1, 1, 1. And multiply the 3. 3 times 2 times 5. 8 times 2, 6 times 5, 30. LCM is 30. And when you follow the same procedure, try to divide by 5 as 6 times 1. It's plus 30 divided by 6, 5 times 2, 10, plus 30 divided by 3, that's 10, 10 times 4, 40. And then we complete the solution by adding the numerators. 6 plus 10, 16, plus 4, 6. That's 6 at 13. Let's try to if I should lose them. 3 in 30 is 15. 3 in 6 is 28. That's 28. Well, 15. I think a final answer. Let's output the proper also for fraction. In the conflict, where they have the ones to do notes. Not subtract 2 over 3 minus 2 over 5. Same question I've proposed one for addition, but then I think in the sign. So let's obtain our values with 2. The 15 divided by with 2 here as 5 times 2 tail minus 10 divided by the 5 close with 2 times 2 or 9. 10 minus 9 is 1 over 10. And second one, 1 over 5 minus 2 plus 6 minus 4 over 2. Here also, as we saw earlier, the LCM is better as we found the so that's the common denominator for all better. Common denominator for all. So we start with value things. After by saying 30 divided by 5 is 6 times 1 is minus 30 divided by 7 factorial. The numerator there is 6. 30 divided by 6, 5 times the numerator 2, 10 minus the third fraction. The bottom number there is 3. 30 divided by 3 there is 10 times the numerator 4 is 14. 42. And that is plus 16 minus 15 over 30. 16 minus 15 as minus 34. 6 minus the other minus 44 over 30. 44 is 22. 28 is 15. That is minus 22 over 15. In that we can see how to subtract fractions in different denominators after the second close. As for by different of subtraction, let's write multiplication. We say we mix it the amount of different subtraction with complex fraction. Upon now let's start with the fraction. We then multiply 3 over 4 times 3 over 9. Anytime you are multiplying fractions, that we see is the common factors. So they can cancel out. This is now 2 here 1, 2 4 is 2, 3 here 1, 3 9 is 3. Right? Then the next thing, multiply numerator by numerator, then multiply denominator by denominator. Numbers up together, numbers down together. Say 1 times 1, 1 over 2 times 2. Other multiply fractions. And then in the event where there are no common factors, you just multiply directly. Example, if we have 2 over 5 times 7 over 10. In this case, there are no common factors cancel out. So we just there is something multiply 2 times 7. Then there are no common factors. Then 5 times 2. Numbers at the top, apply together. Numbers at the bottom, apply together. 2 times 7, 13. 5 times 2, 15. That's it introduction and applying fractions. Even though she actually encounter complex fractions. I'll start with this. Now, for division also, let's just take some fractions just to introduce the concepts to us. For division also, it become let's divide 2 over 4 by over 9. So for division, what we simply do is 3 over 4. Then the division sign here, you change it towards multiplication sign. The 3 over 4 times what do you now do next? The number after the division sign, I mean it's the second number. The number that comes after the division sign, do not invert it. This number at the bottom here, take it to the top. One at the top, take it to the bottom. So that's what 9 over 2. Proceed. I'll say 3 times 9, 37. 4 times 2, 8. Like that. First thing, we change the division sign to what? Multiplication sign. So after doing that, the number after the division sign, invert it, return it numerator to denominator, and return it denominator to numerator. Exactly. Here's another example. 2 over 5 divided by 7 over 3. That's 2 over 5 times, right? 5 times 12 over 7. You can see 3 comes up, 7 comes down. Now, finally, 2 times 3, 6 over 5 times 7, 35. Try to multiply two fractions, 2 factors, simply multiply number by the top together, and also multiply the two numbers at the bottom together. Now we've seen how to multiply, divide, add, subtract proper lower fractions. What if we have mixed numbers, mixed fractions? How do you carry the proper part of them? Example, add this number 1 over 3 plus two number 1 over 6, 1 over 5 rather. Two number 1 over 5 plus two number 1 over 6. Add the two. So anytime you have mixed numbers, what do? You convert them to proper fractions. I think I forgot to mention that before. Okay, you can actually convert a mixed number back to a proper fraction. How do you do that? That's quite cool. Now, for this now, what do you do? If you multiply the denominator here by the whole number, right? Multiply the denominator here by the whole number. 6 times 5, 13. Now add it to the denominator. 30 plus 1, 31. 31 and 5. Like that. In two whole number, 1 over 16. You multiply the denominator here also by the whole number. 6 times 2. That's 3. Add it to the denominator. 3 plus 1, 13. 13 over 6. Then you can now add this to right. Then I'll add equal to 31 over 5 plus 18 over 6. You can also have two factors with different denominators. Find the LCM of the two. LCM of 30. We have 13. 30 divided by 5, 6 times 31. 10 plus 30 divided by 6, that's 5 times 13. 5 times 13 is 65. We have 65. We have 6 times 31 plus 65. 51. 59. 13. There we added the two factors. Okay, so let's see few examples on how to convert from mixed number to proper fraction. We have 2 number 1 over 6. Simply multiply the denominator here and the number root is. So we have 6 times 2 as 3. Add the result to the numerator. 12 plus 1 have 13. 13 plus 2. In this case also, a number 1 over 2. The denominator there is 2. Multiplied by the whole number 10. 10 times 10, 30. Add it to the numerator. The numerator is 1. 30 plus 1, 31. 14. And also here, the numerator here is 6. Multiplied by the whole number root 7 times 7, 42. Add the result to the numerator there. So 2 plus 5, 47 over 6. How we now know how to convert from mixed number back to a proper fraction. So we want to multiply this also. 2 over 5 over 8 times 2 number 7 over 6. First step, convert the two back to proper fraction. How do we do that? For the first fraction, multiply the numerator to split. We have it as the denominator, multiply 8 by 2, right? Is the whole number. 8 times 2, 16. Add it to the numerator. 16 plus 5, 21. 21 over 8. 10 times, not plus, times. Second one is 6, right? Multiply that 6 by the whole number. 3. 6 times 3 is 18, right? 18, add it to the numerator, plus 7, that's 25. 25 plus 2. Are there any common factors that are not without less? 3 in 6 is 2. 3 in 21 is 7. Are there any left? No. Now simplify. Then multiply numerator by numerator. Multiply denominator by denominator. 7 times 25. That's 175. And over 8 times 2. That's 16. That's the answer. Right. Try to subscribe to our YouTube channel. Get more updates.